All right, here we go with a question which is apparently about vectors and also a bit of impulse. Have a try, and then when you're ready to see the answer, watch the rest of the video. Okay, so we've got a ball rolling on the floor towards the wall and rebounding. It rebounds with the same speed and at the same angle. Okay, so we've got a kind of a law of reflection style problem here where we've got the angle of incidence equal to the angle of reflection. Okay, and we want to know what the direction of the impulse applied to the ball by the wall is. Now, I think again with this, we've had a similar problem to this before, where often students don't know the link between these two things. Impulse, you'll find on your data sheet as being equal to the force times the time, or times a delta t. Now that's true, but another way of looking at impulse is that the impulse j, I'll call it, is equal to change in momentum. So j is actually technically a vector quantity. There is a vector which is acting on this thing, and it has delta p as its magnitude, and it's in the same direction. So if we had a final momentum, P2, our delta P is just the change in those. It's P2 take away P1. And another way of looking at it is P2 plus minus P1. We'll talk about why that is in a second. I'm going to now draw the vector diagram so you can see the answer. This is our P2. You can see that's that arrow going down to the left. And then we're going to add this to minus P1, okay, which is a vector acting up and left. Now notice that's not the same as P1, that's in the opposite direction as P1. That's why we put that minus sign there to make it clear that we need to do that. Okay, our delta P is the line which joins these guys together, and so therefore our answer here is D.